Good morning. This is Algebra 1 for 6th and 7th periods. We're going to wait just a few seconds. There's two people. Let me see who those two people are. I see Skylar. Hey, Skylar. I don't see Skylar. I see your name. Dulcinea was here. I think she left. Let me see if that's clear, and then I'm going to get started. I don't know if I'll have anyone else watching today. I wish everyone would watch live. I think it's easier to pay attention when you're watching live. Well, it's a little fuzzy. Let me see. I think it goes fuzzy whenever I get close to my phone. I think I've got some type of magnetic thing going on inside. Uh-oh. My whole camera setup just almost fell over. Looks like Skylar's gone now. I guess I ran Skylar off. It's going to be me all alone once again. That's okay. I'm just going to go on and teach like I have a full classroom. All right. This is Algebra 1, 6th and 7th periods. Today is April the 30th. We have been factoring. This is going to be the last lesson on factoring that we do. We're not covering as much of the chapters as we would if we were at school, so I'm just trying to hit the most important things. So we would be doing more factoring if we were still at school. But I'm showing you the most important things, so hopefully that will stick in your brains a little bit next year when you get into your next math class. Today, we are factoring special cases. That's our goal. We have two special cases. The case is factoring perfect square trinomials. Now, these because they tell you what kind of problem you'll see. First of all, trinomials have three terms, so we're going to be looking at problems just like we have in the last two lessons. They're going to be trinomials, three terms. And they're going to be in the order of your quadratic term first, which is the squared term, and then your linear term, which has just the x to the first power, and then your constant. But the thing about these trinomials, all of them are going to be perfect squares. And for it to be a perfect square, it has to meet certain requirements. First requirement is that the first term has to be a perfect square. And then the next requirement is that the last term has to be a perfect square. And then the third requirement I'm going to wait and show you in just a minute whenever we start factoring this. But if you were given this problem, I'm going to come over to the side over here and show you how you would probably factor it, knowing what you know now. If I told you to factor that, hopefully you would recognize that it's a trinomial and it's going to go into 2 parentheses. Let me see if that's in view. I might need to move it over just a little. And then you would hopefully recognize that you've got to split your x's apart and put x times x in the front of each parentheses. And then at the end, you want your last times your last to equal the 9. And they're going to both be positives. That would be plus 3 and plus 3. Now, and that works perfectly fine because 3 times 3 is 9 and 3 plus 3 is 6. And if you notice, they're the same exact thing. And you can write it this way, x plus 3 squared to the second power, because it's 2 of the same exact parentheses. Well, what we're going to do today is show you how to recognize that it's a perfect square trinomial and take it right to this answer without doing the x plus 3 times x plus 3 part. And all you do is you take the square root of this first term and you write that down, and you use the sign that's in the middle, and then you take the square root of the last term, and then all you do is put parentheses around it and put it to the second power. Now, let me show you where the 6 comes into play. The 6 is just a way for you to check to make sure that it is a perfect square trinomial, because for this to work, your answers in this parentheses, the x and the 3, you have to be able to multiply those together and then double it, which means add another one, and you'll get that middle term. So like 3 times x is 3x, and when you double 3x, you get 6x. So that's how you know that that was indeed a perfect square trinomial, and this is the correct answer. Now that was just a little introduction, and so after you know that background information, let's do these examples and make sure that you understand. Alright, example 1, we're going to factor x squared minus 10x plus 25. First thing you should recognize, it's a trinomial. The first term is a perfect square because it's got an even exponent. The last term is a perfect square because 5 times 5 is 25. So we're going to go ahead and put our parentheses to the second power. Take the square root of the first term. I'm not going to put the square root symbol again around it because it just makes it look weird. But you take the square root of the x squared and you put the answer in front of the parentheses. You put the sign of the middle term, which is minus. You take the square root of the last term, which is 5, and you put it here. Now, that's going to be your answer as long as it checks with the 10. When you multiply 5 times x and you get 5x, don't worry about the sign. The sign just has to match. When you double 5x, you do get 10x, so that lets you know you're correct, and that is your answer. Now, when you do IXL, it's going to give you those, little weird boxes that you have to put it in. I think the first thing you have to hit is the exponent box. Let me just kind of jot it down right here for you. So like you'll see the little exponent box on IXL that has like that, and you'll have to put that in first and then hit the parentheses and put it in here and put your little 2 on the outside. All right, example 2. We're going to factor 9c to the second plus 12c plus 4. So hopefully you see that it's a trinomial. You have perfect squares in the front and at the end. So go ahead and put your parentheses to the second power. Take the square root of that first term, which is going to be 3c. Remember, you just half your exponent. Take the square root of the 9, and that's 3c. Use the sign that's in the middle. And then take the square root of the last term. Square root of 4 is 2. And I'm just going to do a little check. 3c times 2 is 6c, and when you double 6c, you do get 12c. So that is correct. That is your answer. Once again, when you're entering this on iExcel, I know sometimes it can be frustrating on how they want you to enter it. They're going to show you those two little boxes at the end. One, or not at the end, but where you submit your answer. And the first thing you've got to put in is the exponent key. And then once you put the exponent key in, you'll put your parentheses inside of that base. And then you'll put your answer in there with your 2 here. That's how you'll enter it on iExcel. Looks like I have somebody else joining. Maybe it's still Stryler. Example 3. Okay, you've got 49y to the second plus 70y plus 25. So we have a trinomial. The first and last terms are perfect squares. So I'm going to put my parentheses to the second power. Take the square root of that first term. The square root of 49 is 7. Half your exponent, so you get 7y. Put the sign of the middle term. Take the square root of the last term. The square root of 25 is 5. And then let's just check and make sure that when you double this product, you'll get 70. 7y times 5 is 35y, and when you double that, you do get 70. So that is your correct answer. All right, last one on the case number 1 on the perfect square trinomials. This example 4 is different than the others because it has a GCF. Remember when we did the trinomials last lesson, I believe it was on Tuesday, we had to factor out a GCF in some of those. So we're going to have to in some of these too, and it usually doesn't happen until your SMART score is up to around the 30s or 40s, I believe. But always check all these that we've done up here. This example 1, example 2, example 3. Those did not have any GCFs. There were no numbers that you could divide into all 3 terms. But always check, because you have to pull out the GCF if there is one. This trinomial has a GCF. 4 will divide evenly into all of these numbers. So I'm going to pull the 4 out front. Put your parentheses and then just divide 4 into all 3 terms. And when you divide 4 into 4r squared, you're going to get just r squared. And then minus, and when you divide 4 into 48r, you're going to get 12r. And then plus, and then when you divide 4 into 144, let's see, that's going to go 36 times. Okay, so your 4 is your GCF. This trinomial in the parentheses that results from dividing is a perfect square trinomial. So we've got to go a step further and factor this parentheses. So I'm going to write my 4 down in front and then the parentheses to the second power. Take the square root of r to the second, which is just r because you have your exponent. And take the square root of 36. Use your minus. And when you multiply 6 times r together, you get 6r. And when you double that, you do get 12r. So this is correct. That is your answer. Your 4 needs to be in front. Now, it's a little tricky when you enter this on your iExcel. You're going to have to, it might be easier to do the r minus 6 squared and then just move your cursor to the front of it and put the 4. Alright, that's all there is to the first case. Perfect square trinomials. That's what we just did. I'm going to turn it over and do examples 5 through 10, I believe, with something that's super easy. I mean, if if y'all watch this, I don't know if anybody actually watches these videos, but if you watch this, starting with example 5, you're going to think this is the easiest thing you've ever done. It's really easy. So we are on case number 2. Case number 2 is the difference of two squares. Like I said before, the title is important of these special cases because it kind of tells you how to recognize the pattern when you see it. The difference is always subtraction. It always indicates subtraction. So your problem is going to be a subtraction problem always on these. 2 means you've got two terms, and those terms are squares. They're perfect squares. So the difference of two squares means that you're going to have a subtraction problem, and both numbers or variables are going to be perfect squares. Now here's the introduction to that to show you what it's going to look like. X squared minus 16. Remember, if this was x squared plus 16, you wouldn't be able to factor it. It has to be subtraction. And on the IXL problems, they don't try to trick you. They are all subtraction on there. On this problem, x squared minus 16, I want to show you kind of what's going on with this before we actually do our problems. And I know some of you wish that I would just get on with things, but I want you to know why things happen. Let's go back. Let me find a piece of paper I can write on. Let's go back to when we were multiplying things with the FOIL method. And we had a special case of x, something like x plus 5 times x minus 5. And let's say you had to multiply those with using your FOIL method. Well, remember, when you do first times first, you're going to get x to the second. And when you multiply the outsides together, x times negative 5, you get negative 5x. And when you multiply the insides together, 5 times x, you get a positive 5x. And when you multiply the last times the last together, you get minus 25. And so you have negative 5x plus 5x that cancel out, and you get x to the second minus 25. Now, I remember when we did this at school, and I can just picture it. I remember when Jeremiah discovered the shortcut method, and he really got it really quickly, that whenever you have two binomials that you're multiplying, and they're the exact same thing, but one's a plus and one's a minus, the inside and outside terms always cancel out, and you're left with an answer that looks like this. Well, now we're going to be given these as our problems, and we're going to go backwards. So all of our parentheses are going to look like the same exact thing, but one's going to be a 1 and one, plus, and one's going to be a minus. So let's do those now. Because remember, factoring is just what we did when we multiplied backwards. So if this was our problem, x squared minus 16, and you have to factor that, it's going to automatically go into two parentheses. You're just going to take the square root of each of these terms. The square root of x to the second is x, and the square root of 16 is 4. You're going to make 1 plus, and you're going to do another parentheses just like it, except change it to a minus. And it does not matter if you put the plus in the first parentheses or if you put the minus in the first parentheses. That doesn't matter. X plus 4 times x minus 4 is your answer. So example 5, n squared minus 49, you just take the square root of each of these. You'll have one parentheses with a plus and one parentheses with a minus. Because if you had taken this and multiplied it with the FOIL method, the inside and outside terms would cancel out, and you would end up with n squared minus 49. It's just backwards of the FOIL method. Example 6, 16 n squared minus 9. You should recognize it's a difference of two squares, so we're going to put our two parentheses. 16 n squared, the square root of that is going to be 4n. This time, just to show you that it doesn't matter, I'm going to put minus in this first parentheses. The square root of 9 is 3. And then you do the same exact thing with the opposite sign. Isn't that easy? It's super easy. Example 7. We're going to factor 81 j to the second minus 36. Now, there's a bell going off in my brain. Ding, 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 ding. 81 and 36 can both be divided by a common factor. There's a common factor that goes into 81 and 36. And remember, on any factoring problem that you do, if there is a common factor between all of your terms, you have to pull that out. So I'm going to pull a 9 out. 9 will divide evenly into 81 and into 36. So when you pull that 9 out, you're left with 9j to the second minus 4 in the parentheses. Because 9 times 9j to the second is 81j to the second, and 9 times 4 is 36. Now you've got a difference of 2 squares in the parentheses that you can continue factoring. Because if you cover up the 9 and the parentheses, then you're left with a problem that looks just like examples 5 and 6. So we've got to factor that. Put this 9 in front, then make your 2 parentheses, and then take the square root of 9j to the second, which is 3j, the square root of 4, which is 2, and then do the same exact thing with a plus. Just make sure that your signs are opposite. This is a problem that I messed up on last night when I was writing my examples down. All right, and we have one more example. Hey, Hunter. We're about to be finished, but as soon as I finish this up, then you can go back and watch the video. This lesson is pretty easy. Okay, we're going to factor 242p to the second minus 50. Once again, you should recognize that 242 and 50 are both even numbers. That means you can pull a GCF out front. And what goes into all even numbers? 2 goes into all even numbers. And I do believe that is the largest common factor, the greatest common factor. So I'm going to pull a 2 out front and then divide 2 into each term. When you divide 2 into 242p squared, you get 121p squared. And then when you divide 2 into 50, you get 25. Alright, so inside the parentheses, once again, if you cover up the 2 on the outside and the parentheses, 1p squared minus 25, that's the difference of 2 perfect squares. So you're going to factor that, just like we've done examples 5 through 7. The square root of 121p to the second is 11p. The square root of 25 is 5. You're going to make one with a plus and one with a minus. And just put your 2 down front. And that's it. That's all there is to this lesson. We did 2 things. We did perfect square trinomials. And then we did the difference of 2 squares. Your assignment is IXL Algebra 1. And we are going to do lesson 8A6 and get a SMART score of 80. This would probably be a good lesson to try to get to 100 on so you can get some bonus points. The more bonus points you get, the faster your grade will move up. Also, I'm going to be, I believe, doing some worksheets. I'm going to be assigning some worksheets that y'all can do. And then write your answers down and send me a picture of your answers to get some more points because your grades are moving up too slowly. Some of you need them to move up a little bit faster. All right, well, I hope y'all have a wonderful day. I hope everybody does their work and have a really great weekend. Don't forget to take your quiz 3. See y'all later. Bye-bye.